Hey everybody, Tom Cherryholmes here with the FujiNet project, giving another CIO handler status report, also known as the N device, as of May 17th. I'm currently working through debugging the device, as well as doing a first crack at relocation. This isn't the ideal way to do it, especially since the loader doesn't seem to work under SpartaDOS or SpartaDOS X. So what I'm ultimately going to do is use John Halliday's method of doing this, which I will attempt next. But I wanted to show kind of where things are at right now and show one way to basically handle relocation using a pair of action programs which actually take and analyze the binary, as I will go into in depth in just a moment. If we look at what we have currently here, we have the handler directory set up right here. Actually, looks like my little, pardon me here, I'm just slightly moving some windows around here. Let me move that into place, make that a bit more hospitable. Yeah, it's fine. Okay, great. So we have here the handler directory inside of nhandler, inside of the Atari Wi-Fi repo, and inside here we have ndevs, which is a version of the N device handler that has been ported over from the Atari macro assembler to be compilable under MADS. And I did this primarily because John's method of relocation uses a MADS super pseudo directive to actually take and explicitly set labels out of band of the current scope that things are currently in. So I just wanted to take and make this as hospitable as I could so that when I finally do the final relocation method, it will just work. Now, if you thumb through this particular chunk of code, you'll find that there are no relocation labels or anything to indicate that there is any relocation that is actually done. There is, however, a proper reset vector, and if we actually look at the initialization here, we find that as part of the initialization process, we save the existing DOS initialization vector, and we patch that into this address right here, so that whenever the system reset key is pressed, it jumps to our reset vector, which goes ahead, jumps to the old DOS vec, which will return, and when it does, then we do our initialization. So the initialization has to happen beforehand, after which point we take an alter memlo and bounce back to DOS. But again, no relocation here. So how are we actually handling the relocation? I have here, as part of my make file, you'll notice there was one thing of note in the N device, and if you've seen the code before, you'll notice that that there is no org statement. The org statement has been explicitly removed, and the reason for that is that now that the org is explicitly defined in the make file, and if a run address is not explicitly set, then a run address of 2300 is used. If an output file is not used, then the output file is called ndev.com. So if you run the make file by itself, you will get a non-relocatable version of the code that runs at address 2300. But as you can see, you can redefine both the run address and the output file. And my relocation script actually takes advantage of this to generate two versions of the program. The only difference, besides the differing file name, is that they are assembled exactly one 6502 page apart from each other. That is 256 bytes apart. And you'll see why we do this in just a moment. If we go ahead and run the relocation script, we will see our two binaries generated here, each one page apart. It will put those files onto a work disk of sorts containing a copy of DOS 2.0, a memsave file, the two binaries that we've generated, and the pair of action scripts, which I will show now, which essentially take and generate both the relocatable binary and the loader for that relocatable binary. So if we actually dig into these, this is an ASCII version of the code. The version that's on the disk right there is in ATASCII format. But you'll see here a little bit of instruction on how to use the relocator. This is written in Action. And what this essentially does is it takes two file names, or two file specs, complete file specs with device, by the way, and then creates what is called a gen file, which is an action include that you include into the relocator that is essentially a table of differences between the two files. Well, what are those differences? If you have the same program compiled at two different addresses that happen to be one page apart, then assuming that they are the same file, the differences that you're going to find are essentially going to be the high byte of any absolute addresses. And if that's the case, then you can take and replace those high bytes in those addresses with placeholders and make a note in a table of the location, the offsets of each of those placeholders, so that your loader can take, and once it's loaded the relocatable binary into its final location, can fix up those addresses so that the program will run correctly. And that's what this program does. And once that's actually done, then the second program will take those values, which get inserted right here. We'll do that in just a moment. Load the file into memory, fix up the addresses, and then indirect jump to the new run address. So let's see this in action. Pardon the pun. To start, we've created this disk we've created this work disk here, this rel work ATR, and I'm going to copy it over to my FujiNet file server. Get it up and running, ready to go. And we'll turn on my Atari. And we'll go into action. It's already set up, so now all we have to do is make sure we have the relocator work already mounted into device slot 1, so we'll go ahead and hit Option to boot into it. And within a few moments, we're in the Action Editor. Go ahead, we load the relocator generator. We go ahead and go into the monitor because we're going to compile this and run it. Compile. Run. And again, recall that we've created the two binaries here, in dev0 and in dev1. We put those here now. And we'll see right here that we have our binaries. It's creating the offset tables. And here we go. It has now created this gen file which contains the contents of what you see on the screen here. Essentially the table of fixed up relocation addresses, the number of relocation hits, that is the number of entries in that table, and the offset run address, which, since the program pretty much starts immediately after the first binary header, the run address is ostensibly 0. We go ahead and go back into the editor, because we're going to take the resulting file here and we're going to include it into the relocator. We clear out our buffer and we open up the relocator. Now it gives you a little bit of instruction here, and it's giving you a note that whatever code that we have has to be below this address here, so that it doesn't accidentally trample over the relocator that gets put into place. That's fine. We have no problem here, so we just move on. And it's asking us to put the table that we generated into this spot right here. Well, the good thing is if you go ahead and read a file in the action editor, it will place it where your cursor is. Just insert it. It's very nice. It called it ndef0.gen, so we load it. There we go. And there it is, sitting right there, all nice and neat. And at this point, now we can take and compile the relocator. The relocator is compiled, and this time we actually want to write the output. So we write the output to something that we know will actually be useful here. So we go ahead, nd.com, sure, write out the result, and we go out to DOS and see what we have actually sitting here as far as our artifacts. Now we've got our two original non-relocatable binaries. We have the tools that we use to generate the relocatable binary, which is ndef0.rel, the table of the fixed up addresses, which is used to generate the final code in nd.com. Now nd.com is just the loader. It does not have the binary inside of it. To actually use this, we have to take and append ndef0.rel onto the end of nd.com, and for that we'll actually use the append feature of the copy command to do so. We start by basically starting off with the source file, which is our relocatable, and we want to append it onto nd.com/a. Yes, it's fine. We're not going to trample over anything important. And within a few moments, we have a 14-sector file which contains both the relocator at the first of the file and our relocatable binary ready to go. And in fact, at this moment, if we go ahead and rename this to autorun.sys and boot the result, we will actually see our finished product. Now, because I'm removing my action cartridge, I'm going to turn off the machine here, remove my action cartridge, and reboot. And we will go right into BASIC. And we can see right there, FujiNet ready to go. This is a completely non-relocatable binary, and if we actually look at our new memlo, we'll see that we're sitting at 11008, which just happens to be, if I go ahead and I'm going to just kind of scribble on the calculator here real quick. That sits at 2B00. Now this is because we're looking at approximately 3 kilobytes for the whole thing. That is 1 kilobyte of code and 2 kilobytes of buffers. We'll actually try to take and improve this quite a bit, but that's where things sit right now. One of the tasks going forward is to take and try to squeeze that down even more. Maybe by using the cassette buffers, maybe by using the user area in page 4, don't know. But trying to be a bit more intelligent about it. But the important thing here is that we have a driver that has relocated itself down to Memlo. And in fact, if we go ahead now and just use it as is, we'll see that it works just fine. If we hit reset, we will see that it properly survives. We'll see that it works. It's just peachy. And in fact, if I go ahead as a sort of prep here, we will actually take and do a little prefix setting here. Let me go ahead and reboot ever so slightly here. This actually, because this is being written to in memsave, if I take and go basic, it will come back. Ironically, that's easier for me to type. Now, you can see it survived the reset. It has properly persisted itself as part of the. It's properly persisted itself as part of memsave. So the driver is becoming more and more resilient. All good. Now for this next bit, I'm actually going to go ahead and reset my FujiNet, and we're going to do a cold boot so that I can put another disk in the drive here, because I didn't put any FNC tools on here. Hit the reset on the FujiNet, do an E477, and we'll go ahead and I'm going to mount the FNC tools over here on drive 2 real quick. Go ahead and load it up. Go into DOS real quick. And we will set a network prefix for the end device. Now, since I've done this, this becomes a lot easier to manage. But also, now I can do this. The prefix persists as long as the ESP is on. So I am going to shove my ultimate cart back in. We are going to load a copy of Atari Writer version C here. And because it spits out a banner, it's going to throw a little red for just a moment. That's fine. The only reason that actually happens is because Atari Writer thinks that any output to the E device is an error. So it will take and change the banner. But it will continue on anyway. Thankfully, they thought ahead enough to do that. But now, because we've set a prefix, now I can just go ahead and load a file off the web server, for example. There we go. And you can see this relocatable driver is behaving quite well. It's working with other applications. It's doing overall a very good job here. Now, to show that the relocation is actually doing what it's supposed to do, I will now show a prepared copy of the software that I put onto a copy of LightDOS. We'll go ahead and reset. And actually, let me take the ultimate out. So we will take and replace this with a disk image that contains LightDOS and a slightly earlier copy of the driver. And we will boot right into it. Now, by default, LightDOS has a memlow of just below 1,000. That is that's essentially the 4096 byte mark. This moves it up a bit more, so it adds an additional 3K, which puts the memlow at about 1C00. So if we now take a look at the resulting memlow, we can see that the memlow is now at 7168, and you can see now here that that it is completely relocatable. 7168 is equivalent to 1C00. So you can see it is now completely relocatable. The driver is actually behaving quite well, and since I did reset, so I will have to do a full prefix. But you can see that it's working. If I can hit the reset key again, it's surviving. It just keeps surviving. I'll hit reset a few times just to show. Okay, great. Bam, 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 bam. All good. And if we look, we can see, yep, DOS is right there. We have a handful of demonstration programs on here as well. If we go ahead and exit back, it resets. If we run the dumb terminal test, we see that this works just fine. And so on. Again, world's simplest dumb terminal here, using the end device. Bickety bam. So now you can see that the driver is relocating and trying to make the most of memory. It's there. We still have memory that we need to take and squeeze down, get the footprint down, get it working well enough. For certain DOSes, there's still issues. For example, if I take and load back the resulting binary that we put onto our latest disk, we'll see that there's still a number of things that we really have to deal with. We'll go ahead and hit the option key. Now again, because even though we have memsave, and even though you saw the driver just come up right there, when we go into DUP, because DUP is non-relocatable, it's loading at a fixed location in memory, which our driver just happens to be right on top of. If I actually try to use that driver, then you can see right here it just straight up freezes. That's it. Boom. That's all she wrote right there. And it can't reset now because DUP has now completely clobbered over my driver. So I'm going to have to come up with a relocation method that will allow me to take and put this into different memory locations so that different disk utility packages can effectively use the package. Now, if I take, for example, and load what we've built here in something like SpartaDOS, you'll see that it basically chokes on the loader. We'll go ahead and load it up just to see. Our files right here, and if I go ahead and run autorun sys, you'll see that it fails almost immediately. It'll just freeze. And that's not the relocatable binary. It's not getting past the loader for whatever reason. However, if I take okay. Does cold exist here? No. Okay. However, if I take now and try to load the non-relocatable version, you'll see that it actually works. Either one, it doesn't matter. Boom, there we go, and if we go out, it's just having a grand old time. Oop, did I not put dumb? I didn't put dumb term on there. Okay, never mind. So, I mean, you can see that it actually works just fine. Interestingly enough, if you set a prefix here and try to do, because I don't do any input checking on open, it will attempt to, and you set a prefix, it will attempt to return the page that you did if you try to do a directory. It's just to show that basically that very open-ended and that I have to do a lot more processing here. Much the same story on SpartaDOS X. Now, with SpartaDOS X, the reason that we need to do a kernel will become evident in just a few moments. Kernel driver. So we start by going ahead, and I will just kind of shuffle some things around a bit here. Bang, bang. Go into rel work and just mount it. Bam, bam. Yeah, go ahead. Well, it doesn't matter. So go ahead, hit option, and I'll go ahead and do that while that happens, and then we will turn on SpartaDOS X and boot the result. So far so good. We take a look here, and if we run autorun sys, we'll see much the same result here. So I won't do that. However, if we run the non-relocatable version again, we'll see that it's ready, but because it's loaded into a fairly high address, if we look at mem right now, it's like, holy crap. There you go. So there's a reason why we need to take and push this down a bit. So right now, you'll recall that this is for the end device. If we actually try to do the end device inside the SpartaDOS command processor at this moment, it's thinking it's trying to access a disk drive. There's no way it can deal with that. However, if we go out into basic, and again, much the same game here, basic has no problem using it because basic is basically just using CIO. So there we go. CIO working as expected. Bam. It does work, but in order for us to really use this integration inside of SpartaDOS itself, we need to take and make a device driver. And of course, if we actually take, for example, and load up into another OSS DOS, such as, let's say, OSA plus 4.1, just as a weird little example. Oop. Let's excuse me. I keep hitting the wrong key. Okay, let's turn off SpartaDOS X for right now. And since I've got FujiNet reset, it will go into config. And we'll go ahead, as far as our next one here, go into my SD card slot here, go to OSS, load up a copy of OSA plus 4.1, mount it read-write, because I'm going to take and copy over that handler. And we're going to load, of course, rel work and here. Mount that as read-only. And we're going to boot this. Bam, there's OSA plus 4.1. Go ahead and get the AtariDOS FMS loaded into place here. And we're going to take and copy to 4. Copy it over real quick. And rename that to ndev.com. Just kind of put it here. Okay, there's ndev.com, taking 7 double density sectors, so 14. We go ahead and we will redo a cold start. And I think I put memlow on here. I'm not exactly sure. No, I didn't. Okay. So if we go ahead. Looks like a slight little incompatibility here with DOSVEC that I have to deal with. Okay, so never mind. You can see more that we have here. Oh, but it loads. Oh, fun, fun, fun. Okay, so it's not okay. So the DOSVEC doesn't load exactly right. But I'm willing to bet that the non-relocatable version will run just fine, with a little bit of tweaking. And of course, for DOSes that actually have a binary file loader, binary files, of course, will load. But in order for us to make that work for example, with MyDOS and SpartaDOS, I will have to include a binary file loader into the CIO handler. Roughly about 160 bytes or so. So that's really where things are at right now at this particular point in time. More to come. It's primarily at this point debugging Lots of little edge cases that have to be dealt with to make sure that when you open up network connections that you get all the bytes in from a channel that you're supposed to. Handling disconnects appropriately. Making sure that we don't drop any packets that we're not supposed to if we're doing UDP, for example, and so on. So a lot more to do, but it's moving along. And so more to come in the next few weeks. I'll take and record a video soon. Until next time, guys, have fun.